Okay, so we went over the common log, which is when you have a log with a base 10. There's also the natural log, which is a base of a number called e. E represents a irrational number that's approximately 2.71828, and it continues on. If you ever see in the calculator, you'll notice it has e raised to the x. That e represents a number. That's one reason why e is never used as a variable, because it represents a number. Okay, and as a log, we write it. You don't write log base e of x. It's just ln of x, and it's the natural log is what that's referring to. So what you can notice here, you can write an equivalent base e exponential equation for a natural log equation by using the fact that ln of x is equal to log base e of x, which is what I just kind of went over. So ln of 4 equals x, which means log base e of 4. When you see this, you have to understand all that means is it's a log with base e. That's the only different thing we're doing in this section from things that we've already done. Everything else is things that we've already done before. So to change it to exponential form, you keep the base e, then go away, raise to the x, come back is equal to 4. E raised to the x is equal to 4. So to write these in log form, I'm going the other way. Log base e, well, that means it's going to be ln of 23 come back is equal to the exponent x. And the same thing here. Sometimes I'll write it capital because I just use capital letters. ln just means I've kept the base already, e of, go away, x, come back is equal to the exponent of 4. And going the other way, writing it in exponential form, you see ln of x, well, that's a base e, keep the base, e raised to the 1.2528 is approximately x. Same thing here, keep the base, e raised to the, go away, x, come back is equal to 25. So it's pretty much the same thing we've been doing. It's just you have to notice when you see ln, that's the base e. So go ahead and rewrite these real quick. The first two write in log form, the second two write in exponential form, and I'll give you those answers in 3 seconds. And here are your 4 answers, just to make sure you're doing that part correct. And so now you're using your log properties in order to put these into a single log, and you can use the same log properties in order to expand it into several different logs. Well, this first one, remember, before I can combine these two logs into one log, this coefficient to the log has to go to the exponent. So I have ln of 3 raised to the 4th plus ln of 6. Then you can actually simplify this and you get 3 raised to the 4th. Well, I'm going to go ahead and do that in the calculator if you need to. 3, this x raised to the y, remember, is your exponent. So 3 raised to the 4th is equal to 81, and then 81 times 6. So I'm going to have ln of 486. And I can do the same thing here. Again, remember before I put them together, I'm bringing that exponent. So it's ln of 3 squared plus ln of 4 plus ln of y. And all of these are being added, so I'm going to multiply them all. Ln of 3 squared, well, that becomes 9 times 4 is going to be 36 times y. And so I have ln of 36y. Again, these steps are the same as using the properties of logs, just you're doing it with a natural log now. So for this one, we're going to solve it. And you have 3 times e raised to the negative 2x plus 4 is equal to 10. Well, in order to solve it, you have to get what's being raised to the exponent by itself. So I'm first going to subtract the 4, and I have 3 times e raised to the negative 2x is equal to 6. I still need to divide by that 3, And now I have that e isolated by itself. And now I can do the change of base, or I'm sorry, I can change it to log form. Log base e, well, that's going to be ln of go away 2, come back is equal to negative 2x, and divide by negative 2. So I have ln x is equal to ln of 2, all divided by negative 2. And when you're typing this in the calculator, you can, the way you can do it in this calculator, you type ln of 2 in the parentheses and then divide by negative 2. My negative sign is not this one, but this one, negative 2. And I get x is equal to negative 3466.3466. And it actually is approximately equal to because I rounded. Notice you can do the same thing and just do ln of 2 equals divided by negative 2 equals, you end up getting the same answer there. We'll shorten this up. We'll take off this one. You go ahead and try this one, and then we'll move on. And so when solving the natural log equation, it's again the same thing. I have to get this natural log by itself though. Okay, so for this one, that log is being divided by, or being multiplied by 2, so I'm going to divide by 2 and cancel those out. So then I have ln of 5x is equal to 3. Now I can solve it by e raised to the third. Keep the base, which is e, go away, raise to the third, come back is equal to 5x. And then divide by 5. So I get x is equal to, and go to the calculator. So my e raised to the x is right here, raised to the third equals, and then divided by 5. So I get x is equal to approximately, what, 4 point, and I'm going to have 0.171. I'll show you the answer to this one in 2 seconds. Hurry, hurry. So you get x equals e raised to the 8 over 5, all divided by 6. If you're doing that in the calculator, you can do exactly that. E raised to the 8 over 5 in that parentheses, and then divide that by 6. And you get x is approximately 8255, 0.8255. Okay, so you have one more formula that we're going to use with interest, and you use this formula when it says compounded continuously or continuously compounded. Instead of, all it is instead of the 1 plus r, you're using e, and the rate is in the exponent. This p is still the p. The a is the amount in the account after t years. The p is still the principal, how much you started with, your initial amount, and your r is still the annual interest rate. So if you have this scenario, suppose you deposit $700 into an account paying 3% annual interest, compounded continuously. So what this means is this wants what is the balance after 8 years. So for this one, I have 700 is going to be my initial amount or my principal. The R is my rate, so that's 3%, which means I'm going to be using 0.03, and my T is the number of years, which is 8. I'm looking for the A. So I have A times 700, or I'm sorry, A equals 700 times E raised to the 0.03 times 8. So let's do 0.03 times 8 is going to be 0.24. So I have e raised to the 0.24. So now I'm going to do e raised to the 0.24. I went ahead and fixed that, equals, and then multiply that with 700. Let me write that down first. A equals 700 times 1.27, so forth. Keep it in the calculator. I'm only writing 1.27, but notice I'm keeping it in the calculator and multiplying that with 700. I didn't just multiply 1.27. It's important to keep it in the calculator to get the accurate number. So I get $889.87. I'm referring about money. So $889.87 is how much is in the account after 8 years. How long will it take for the balance in your account to reach at least $1,200? Well, that means the A is the 1,200 here. My initial amount was still 700. My rate is still 0.03. What I'm missing here is the T. I want to know how many years it will take to reach that. So when I'm solving this way, I'm solving it, so I'm going to divide by the 700 first. I'm going to leave it as a fraction. So I get 12 over 7. I'm reducing that by 100 equals e raised to the 0.03t. And so now I can change this to log form, which is log base e, which is ln of 12 over 7 equals 0.03 times t. And then I'm going to divide by that 0.03. So I'm going to have ln of 12 divided by 7 equals divided by 0.03 equals, and I get 17.966 years. I'm talking about the t here, so I'm going to round up to 18 years. You're going to need that 18th year in order to reach that amount. So in this one, it's saying how much would have to be deposited in order to reach a balance of $1,500 after 12 years. So I want $1,500 after 12 years. I don't know the principal in this case. The interest rate is still going to be the same. And my number of years is going to be 12 in this case. So in this case, I'm looking for the P. So I got to go ahead and find what this is. And so I'm going to take, so I have 0.03 times 12, which is 0.36. And what I can do, I'm going to do e raised to the 0.36. I'm going to want to divide by that. You can do it like this and type that in the calculator and you will get that P, because these will cancel out. Or you can do it this way. I'll show you two ways to get the exact answer. So you can type 1,500 divided by, and my last answer was that e raised to the 0.36. So I'm going to put A and S. That represents the previous answer, and then press equals. So P is equal to 1,046 and 51 cents. Notice you could have also done 1,500 divided by e raised to the 0.36, and I'm going to end up with that same answer, 1,046 and 51 cents. What has 10 letters and starts with gas? Automobile.